Do you know that wind energy requires an input of electricity to be able to run properly? Does wind energy still count as a renewable clean energy source if it uses electricity from the grid? Well, this has been bugging me for some time now, and I truly believe that the efficiency rate of wind energy will increase dramatically if the input of electricity can be eliminated. And that is why I had an idea for programmable turbine technology. Let me explain the problem. Wind turbines have a lot of sensors and components to run properly and to ensure the wind turbine safety. Well, all of these components combined can theoretically consume about 50% of all the energy produced by the turbine. And wind farms does not work as we thought it would. Wind farm actually does not use electricity produced by the turbines to power other turbines, but it uses electricity from the grid to power those turbines. And this process will decrease the net energy output, increase the usage of electricity produced by fossil fuel to harm the environment, and is very time consuming for the workers to monitor these turbines 24/7. And here's why I have my solution for this. My solution for this problem is to combine wind technology with programmable materials. Well, in here, I will only explain the most used braking system, blade pitch, control system, and how programmable material can eliminate electricity on that function. But all of the functions of the wind technology can be used with programmable materials in a similar fashion. Now, before we get into the details of my solution, you have to know some basics about blade pitch control system and the programmable material itself. Blade pitch control system is an important component of wind turbine. If you don't know, wind turbine is a device that rotates to convert kinetic wind energy into electrical energy, which is electricity. And to ensure the safety of the wind turbines under high wind speed conditions, some overspeed mechanism have to be used. And the most commonly used overspeed braking mechanism is the blade pitch control system. The blade pitch control system works by changing the angle of the blade, so if the angle is smaller, there will be more torque or rotation produced by the turbine, and if the angle is larger, then there will be less torque or less rotation produced by the turbine. And this technology allows the wind turbine to work consistently under most wind conditions. Programmable materials are materials that are highly dynamic in both form and functions. These materials have certain compositions or surface patterns that allow it to be highly dynamic to take on certain actions without the help of any electrical powers. Well, the programmable material used in this case is called SMP. SMP is shape memory polymer, and these polymer can be altered but change back to its original shape before altering under specific external stimulus, and in this case we want heat. Researchers are currently developing a two-way SMP that allows it to be altered, change back into its original shape in higher temperatures, and change back to the altered shape under cooler temperatures. And this technology is essential to the programmable turbine technology. The blade pitch control systems requires a blade to turn into different angles for it to work. And this process is normally powered by electricity powers. But with the help of SMP, the programmable material, it will move into different angles without any help from electricity. Well, how this works is that the SMP will be installed on the twisted side of the blade, and when the heat from the generator is conducted through the blade to the SMP will curve in a certain direction according to the temperature. And this can be applied on all functions of the turbine, including yawing, furling, and many more. This will eliminate the use of electricity on the turbines completely, and that's it for my idea. If you really like my idea, you can find my LinkedIn and my email in the description box below. If you would like to read more about my idea in my explanation article, you can find it down below too. Thank you for listening, and I'll see you next time. Bye bye!